I'd like to introduce today's speaker. Greg Pierce is the Business Development Manager for Sumitomo Electric Lightwave's fourth-level enterprise and data center products. Greg has 30-plus years of experience in the industry and is based at Sumitomo Electric Lightwave's facility in Raleigh, North Carolina. Greg, over to you.
All right. Well, thank you very much, Joe, for that very nice introduction, and good afternoon and good morning to some of our folks out there. So today I want to talk to you about recent fiber cable and hardware advances that are affecting data center design. This is a fairly broad topic, so we're going to touch on several different aspects of it, but hopefully give you some information that maybe some of it you're already aware of, maybe some you're not, but hopefully bring you up to date on the latest things that are affecting those designs. So for the agenda today, I'm going to touch on 4 different categories of products. First will be optical fiber and advances that are happening there, and things that we see in the future, and how those can impact the data center. Cables, how they're evolving to address the changes in the fiber and that type of thing. Connectors that we use in the data center, as well as then lastly hardware. So those would be the 4 topics that we'll touch on. So first of all, let's talk a little bit about optical fiber. And one of the big developments that we've seen in recent years with optical fiber is a change in the style of ribbon fiber that we have out there in the industry. And of course, I talk about ribbon because now we're getting so much fiber, there's so much fiber demand that we're seeing a lot more ribbon cables in the market, and a lot more people going to ribbon to be able to accommodate their needs. And what we've seen, of course, the conventional ribbon that's been available for many, many years was a flat ribbon, not unlike a ribbon, you know, a normal ribbon that you tie a bow with or that type of thing. But it was a flat ribbon with your 12 or more fibers, 24, 36 maybe, in a flat plane. And what has happened in recent years is we've had the advent of pliable ribbon, or the development of pliable ribbon. And with pliable ribbon, you essentially have, and there are different styles of it depending on the manufacturer, but it all boils down to having some separations between the fibers within the ribbon itself. So rather than a conventional flat ribbon where all the ribbons are held by a substrate in one flat plane, the pliable ribbon, they are essentially interspersed almost with spacing. So what that allows you to do is it provides a design where the fibers are not all connected together, and then once you have that, you're able to the ribbon becomes pliable. It's not just bendable in the one ribbon direction, but it's bendable in other directions. It can fold, it can roll, it can be free-forming. I'm using some of the names out there that people use for this kind of fiber, but it gives you much more flexibility. So that has been an important evolution in development in the last few years, and it's really affecting how we move forward with fiber and cables. So if you think about prior to that development, and then we'll talk a little bit about the ribbons as they apply to cables, and we talk about standard flat ribbon cable. Of course, you always had, when you had flat ribbon in a cable design, there was always a certain amount of kind of dead space or airspace in there that was not being used just due to the fact you're putting a square peg in a round hole, more or less. And so with the advent of pliable ribbons, then you're able to get more fiber in that particular round area. You're not dealing with again, a square peg in a round hole or a rectangular peg in a round hole, but instead you're dealing with something that can more free form to the size of that diameter. So what you get with that is the ability to have smaller diameter cables, lighter weight cables, and of course all these things are more efficient, so they generally are going to reduce the cost of the cable, and then you have higher fiber capacity per the prior envelope. So if you think about, say, an 864 fiber cable, what that looked like in years past as far as the diameter, now we're able to get a much more dense amount of fiber in that size cable. So now roughly, roughly a 1728 fiber cable is the same diameter as an 864 was in the flat design years ago. So of course there's many different styles of cable out there, so this is just a general comparison, but it gives you some idea how much of an advantage you get into with the pliable ribbon. And other things that affect your ability to use pliable ribbon are things such as storing it on splice trays, storing it in enclosures if you're doing it in outside plant, or in the cabinets and routing it within the cabinet in inside plant, or inside wall mount housings, whatever, the panels. It just makes it in many ways easier to work with. Now, another advance that that we're seeing in the marketplace is, and there are multiple advances as far as the diameter of the fiber goes, but we're seeing a 200 micron fiber now take a bigger position in the market, and it's a smaller coating on the fiber itself, so the core, of course, is no less size, it's the same size, but it does end up being a smaller diameter fiber, which ends up providing a smaller diameter cable than you can have with a 250 micron. And these designs are also making their way into the pliable ribbon design cables, so therefore you get the advantage of the size difference just by the sheer diameter of the fiber, and then being able to put that into a pliable design, have it that much smaller. So it's a couple of advantages there. I think there are some designs out there even smaller than 200 micron, but of course the smaller you get, then you've got trade-offs with maybe handling ability or losses and things you may see in the fiber. I'm no expert on that, so but anyway, so these continued fiber diameter reductions are taking place in the market. And of course, when you start talking about 200 micron and 250, and people start thinking about, well, I've got 250 in my network, how do I handle 200, that type of thing. What about, can I splice them together, for example? And our company, Sumitomo Electric Lightwave, makes splicers and equipment that definitely handles that. There are others in the market as well, but just so you know, that is possible. There's not necessarily a downside to doing that. So now a couple of other developments that are going on in the world of fiber, and there are really two kind of major ones out there. One is called hollow core fiber, or maybe you might call it air core fiber, but there's no glass in the core of the fiber. It's actually a fiber without a center to it. Now that is, again, just air. Of course, the speed of light is going to travel faster through that than it would in glass itself. So that type of cable provides a lower latency. I know Microsoft is one company that is invested in that technology. They did that in late 2022, buying a company in that space. And I think there are some commercial users of that technology at present. It's a very low latency So you can imagine that be it scientific areas, be it, just any number of areas where extremely low latency or having the lowest latency possible it becomes that much more of a competitive advantage. You can see where that fiber can certainly play a part in those areas. And another type of fiber that we're seeing just really still in the development stages, but starting to come out of it maybe a little bit, and that is multi-core fiber. And it's very interesting. You have multiple cores within a single small fiber, which as you know, the size of fiber being so small, you wonder how can you get additional cores in there. But there are designs out there, and fiber's been made. I think with we have on the right photo there, I think it's 29. I'm not able to see that detail presenting at this point, but it's something like 29 different cores in that particular fiber. But certainly 4-core has been made and shown and displayed at trade shows and that type of thing. I know Sumitomo Electric Lightwave has displayed that technology at trade shows. So there's a couple that at this point are very early into the marketplace. Multi-core, I guess, not really in the market yet, to my knowledge anyway, but they certainly could have some advantages down the road. I know when it comes to multi-core, some of the things that you hear about are possible uses of that in subsea fiber. So it may not be, in typical data centers, but subsea and, where you do have real tight spaces required and just do not have room to add additional fiber, then multi-core fiber might be the way you can go in those situations. So now, we've talked about the fiber. Now let's talk about the impacts on the cable. And recent advances in fiber optic cable have really benefited from the advances in the optical fiber itself. The pliable ribbon and those continued design evolutions have made for, again, reduced cable diameters. So we've seen significant reductions in cable diameters. Or, as I said earlier, cables that were the diameter they were for 864 are now holding 1728 fibers, and so on and so forth. And of course, when you reduce the diameter, then you're able to reduce the cable weight. That also improves the ability to jet the cables or air blow fiber because of, again, lower weights, easier to process it through. So all this helps to offset increased fiber and fiber cable needs in the DC. Can help with the efficiency of it, help everything be smaller and hopefully less costly in the end. Here's some comparisons just to show you some of the different size comparisons. So you can see here, looking at freeform ribbon versus, and freeform being the Sumitomo version of the pliable ribbon versus flat ribbon, and you can see the change in that in both riser and plenum cable applications. We've got diameter changes of 50%, 30%, 20%, which are big reductions in diameter. And then look at some of the weight reductions here: 83% reduction in weight, 100%, well, a 50% reduction taken. So significant reductions in weight on some of these cables. Now, some additional cable design evolutions that are going on out there are, and some of these are available at certain places, other people are still developing them, but like indoor-outdoor cable developments that are both plenum, riser-rated, indoor-outdoor low-smoke halogen-free cables that can assist with construction where it's very tough requirements, maybe going into areas where there's not a lot of air moving, that type of thing. Subunitized cable evolution. So we're talking cables where they're cables within a cable, essentially. And so you're able to, once you open up a cable, we're able to run the subunitized, the smaller cables to different pieces of hardware. For example, if you're thinking about panels in the data center, running those subunits maybe into specific cassettes in the panel, that type of thing. So lots of different design evolutions out there for that kind of product as well. And you can see over on the right-hand side, I've got some different pictures of some different subunitized cables, different quantities of fiber within them, etc. Then monotube cables. Now, some people may call these unitube or whatever, but it's cables where with just ongoing developments, we've been able to get rid of maybe an inner layer within the cable, which obviously can reduce size and weight of the cable as well, and make it possibly easier to handle, easier to access, and yet still provide all the benefits of what the cable needs to do. Now I want to switch over to optical fiber connectivity and speak to that for a moment. So if we think about the connectivity piece, many of us are familiar with SC and LC connectors, been around for many years now, and LC being half the size of SC, more or less. And we know now that LCs are getting down to the size where they're pretty small, and the more dense you make those, the tougher it is for technicians to get in there and work with them. But those are still common in the data centers for single fiber connectivity. The densities range from about 144 connections per 1 RU, or that's kind of the max density. So in a 2 RU, if you think about an LGX formatted 2 RU panel, where we would have 144 fibers in that panel using LC, say LGX cassettes. If you go into a higher density with those LCs, that doubles that. That's 288 LCs in a high density 2 RU flat front, and that's they're getting pretty tight in there once you do that. So as obviously with that, and with more fiber going into the data centers, the need for more fiber to meet the bandwidth requirements, then we've seen the development over the last several years of multi-fiber push-on connectors, MPO and MTP, the US Connect version, and these are high-density connectors that have been standard now for many years. They have a footprint that's an SC, LC duplex type footprint, but obviously the density, because you can get 12, 24, 36 fibers in these MPO, MTP connectors, the density goes up significantly from there. So if you think about a 1 RU, that means we've gone from a range of, say, 72 fibers in an LC, LGX format to now 34, 56 fiber connections if you have a fully populated MPO, MTP faceplate. So it's a big transition that we've gone through as far as increasing the density. And if you think about it, those transitions really aren't easy to deal with unless you have the transitions in the cable that we've already talked about, with being able to make the cables smaller diameter so you can get all the connectors back into the panels and that type of thing. So that's one of the areas of fiber connectivity. Another one that's very interesting that's in the market is called a SWIC connector. This is one that Sumitomo markets, and it has multiple MPOs per a single fiber connector. So if you think about an MPO to MPO connection, this is multiple MPOs to multiple MPOs in a single connection. And that has density right now up to 144 fibers. That's 4 36 fiber MPOs. And I know the development's working on even going up higher than that, but that's quite interesting to think about 144 fibers in essentially one connector. Now, it's not certainly the footprint of an MPO, but it is still a single connector. So a single connector. So a single action from plugging those connectors together, and you not only wipe and clean the MPO, which of course cleaning in the data center is, when you're doing connections, is always critical. So you have to clean, when those MPOs get cleaned, then with this connector, it wipes those MPOs clean and then connects off for the MPOs. One thing I forgot to do a little bit earlier, and I'm going to stop right now and ask a couple of polling questions. And I did want to do that a little bit earlier, was first of all, I wanted to ask, for those of you that have, or how many of you are familiar with pliable ribbon or have been working with pliable ribbon? Let's see. Joe, I don't know if you could put that polling question up. I guess let me switch over to the...
Yep, we've got it all taken care
there
of.
we go.
We've sent that polling question out for the attendees.
Okay. Apologies there. And receive any responses on that. Okay, so interesting. We're getting responses at, you know, it's about 50-50 on the pliable ribbon. Maybe actually a few more people that haven't had experience with it or been working with it or have much knowledge about that. And that's not unlike what we see at some of the trade shows, to be honest with you. Even though that design's been out there for a few years now, different manufacturers and things, still there's a lot of people that are used to using the flat ribbon fiber that have not seen the pliable ribbon yet. So if you haven't, I suggest you call up our team or your companies of choice and talk to them about those designs. It's interesting. They certainly have some advantages over the flat ribbons. There may be some disadvantages too, but I think the advantages for most people are outweighing those disadvantages. And then I would like to go to the second polling question as well, because that dealt with something similar again on the fiber. And go ahead and toss that one out, and that is the, okay. Thank you, Joe. And that one has to do with, and I don't know how we get this on the screen. Sorry, Matt and Joe. Is it populating the screen now, the second one, or do we need to wait?
You should see that on your screen. The attendees are seeing
okay,
that.
I've got it. I've got it. Yeah, got it. So yeah, on the 200 micron, my apologies. On the 200 micron, yeah, this is not unlike what we see with the pliable ribbon as well. This one's maybe a little bit newer in the marketplace, and so I can expect that more people would not be familiar with this. I think where this is playing a role right now is with really the very large data centers, the hyperscale data center type customers. For others, there's really not been a need to evolve yet to the 200 micron, but there is, it is out there, and as data center get more and more fiber rich and need to save space and things, then this is an area to look at as far as smaller cable design and that type of thing. Let me go back to the slides here, and I'll jump back onto connectivity. So, and just back on the SWIC connector. So this particular connector, again, one piece connects multiple MPOs together, or one connector connects multiple MPOs together. And you can see there are a variety of products that go along with that, from panels to, cable assemblies of different types and things. So these are factory-built connectors, so it's not something you can build in the field. But again, you get a lot of connectivity in a single connector. Now, another area that's really evolving and evolving quite quickly, it appears, and that is very small form factor connectors. And some of you may be familiar with the MDC and SN two-fiber connectors, MDC being US Connect and SN being Synco, two-fiber connectors that have been around for a few years now. And they have a small footprint, smaller really than an LC, maybe about a third the size of an LC, something along that line. And now we're nearing commercialization, it appears, of higher versions that are very similar in footprint from that standpoint. And when I say higher numbers of fibers in the connector. So we have the SNMT, which is the Synco product, and then the MMC, which is US Connect product. And those both have the ability to connect multiple fibers in that very small, again, very small form factor footprint. So we're talking about a footprint that's, again, about a third the size of an maybe it's a third the size of an SC, but definitely smaller than an LC. So that is going to looks like it's going to be. There are certainly some hyperscale customers that are looking at that technology, maybe using it. I can't really say in that level of detail, but certainly that technology is evolving, and it's going to make the amount of fiber density significantly more dense. So let's talk about the hardware, and we'll come back to that a little bit. First of all, when we talk about the hardware in the data center, we've got the cabinets, the different style of cabinets, the freestanding, the wall mount, the rack mount cabinets, rack mount panels, the patch panels that we also familiar with, and of course the interconnects, the splice cassettes, and the MPO MTP type cassettes that are out there. So these are the kind of products that we talk about when we're talking the hardware. And when we talk about the cabinets, obviously with the demand for fiber increasing, then we need cabinets that can adjust to that and be able to handle more in a smaller space. And obviously with the cables getting smaller and with the use of pliable ribbon, then that enables us to make smaller cabinets and to have more flexibility to them. So for example, the cabinet here, Sumitomo cabinet that you see here on the right, if you notice, there are multiple cable entry ports on this, on both sides of the cabinet, because as those cables get smaller, you can bring in more dense, you can bring more of those cables in and out. So it really affects the ability to do more within a small package. So those cable and fiber styles are really driving the flexibility to handle of these cabinets to handle multiple cables. And then rack mount panels and cassettes. We've seen over the years that panels have gotten more dense with from the LGX style and even less dense styles than that in the early days to now HD designs where we've got upwards of 288 LCs in a 2RU. So we are getting to the point where, at least from an LC standpoint, it's getting difficult to be able to work with that with technicians without the use of either special tools or having the pull boots and that type of thing built into the connectors, which is certainly available. Also, with these evolutions, we're seeing factory-built products like pre-terminated and pre-stubbed panels, where the factory then, because of the tediousness of that work, the factories can take that on and pre-terminate and just leave splicing up to the field and let the field bring a cable in and splice it, or maybe there's a pre-stubbed cable coming out of a pre-terminated panel, and that pre-stubbed cable could even be connectorized and just plugged in. So there's a lot of varieties there of custom panels like that. And then also the use of these MPO and MTP type connectors and very small form factor connectors in panels. You can imagine how once we have those becoming more and more commonplace, how dense the panels can get. And along that line, we actually have a product, and this is kind of an older product reimagined. It's simply a rack mount splice enclosure that will handle 1728 fibers in a 3 RU. So, you know, that's a lot of fiber if you think about it. That's significantly more than could have been handled just a few years back. But we can splice 1728 in a 3 RU. So if you think about that, what that means is in a 54 unit rack, we could go from having what was 5,100 fibers in a rack like that to now having something like 20,000 fibers in a rack like that. And that's with, you know, approved connectors with good splicing capacity in the rack mount panel and that type of thing. So it shows just how we're able to improve on the density in that area. So this is kind of a summation, if you think about it, of what we've talked about really up to this point, which is the fiber developments on the ribbon side, impacting the cable developments, making those smaller, impacting fiber connectors and being able to get more density in a connector, and then the hardware being able to accommodate that. There's one more polling question I'd like to have us go to, and that one has to do with MPO and MTPs and very small form factor connectors. And it is, are you currently using or planning to use the MPO or MTP type connectors or other very small form factor connectors in the next 5 years? And we're seeing those results start to come in now. Well, it looks like most people are familiar then with either one or maybe both styles and are using those in their networks. Certainly they're becoming more and more popular, and again, these very small form factor designs that are hitting the market are have a lot of potential for very high density in the panels. So it looks like most people are familiar with that. That's good to know. And I'll go back to the slides here, and then just so a final slide. So with the continued evolutions in the optical fiber, and the cables, and the connectivity, and the hardware, all this is significantly impacting and benefiting our data center designs. It's making them making them more efficient, lowering costs, being able to, you know, save weights in the cable trays and all that type of thing. So with that, I'll turn it over to questions.
All right. Thank you so much, Greg. We do have some questions. I'm going to read the question from you, and yeah, we'll go from there. We've got some good ones here. Let's start here. So, Greg, what is the impact in the splicing process of a ribbon fiber versus a pliable fiber? Can you still splice 12 fibers in one shot?
Yes, you can. It's and I'm not a splicing expert, but there are pieces of hardware in the market that help you to basically align a standard ribbon with a pliable ribbon set of fibers. And so those tools, those holders, allow that to take place. So obviously you're using a ribbon splicer at that point, but it does allow you to do that.
Excellent. Okay, another one here. Is there a cable fiber count that is more common or typical for the 200 micron fiber solution?
Well, I think the higher fiber counts, I don't know that there's one in particular, but higher fiber counts are typically going to be where most of that is prevalent. I think, you know, obviously the higher fiber count, even with the pliable ribbon, the bigger the diameter of the cable, which makes it more difficult handling, both in the outside plant and then whatever size cables you're using inside. If you're bringing in any large cables inside the data center, it makes the bigger the diameter, the more weight, the more difficult they are to handle. So I think it's the focus on right now on the 200 micron is going to be in higher fiber counts. I would say anything from 864 on up. Again, I can't speak to it knowing which area is the most popular other than for larger fiber counts at this point.
Okay, and then what connectors or termination is used with the AirCore multi-core fibers?
Yes, now that I really cannot speak to that at all. I'm not familiar with that. I know that as far as multi-core fibers, we have displayed that at trade shows. Sumitomo has, there was one at OFC earlier this year showing that with 4 cores in it. But how they do that, I do not know at this point. So I'm sorry, but I'm at a loss. Somebody else will have to answer that one.
It's okay. Thank you, Greg. Okay, so can the MPO be used with the 200 micron ribbon fiber, or is that size targeting fusion splicing?
That is a very good question. I do not know the answer to that either, unfortunately. I know, you know, it can be fusion spliced, but whether MPO or MTP has been adapted to 200 micron, I simply don't know. I should know that. My apologies. Very good question, though.
Yeah, okay, great. And then do you see a need for combining multi-core fiber and MTP or SWK connectors to continuing to increase the rack unit bandwidth density?
Let me see. Can you say that one again? I'm scrolling here to see if I can find that.
Oh, yeah. Number 9 there.
Okay. Yeah. Okay. You know, that's a good question. I don't know enough about multi-core at this point and the complexities of it, the difficulty of connectorizing it or that type of thing to really be able to answer that. But it's a good question. Certainly with the other very small form factor connectors that are on the market, you certainly wouldn't compete with a multi-core fiber, but the density is getting quite dense now, and if you think about it in a per 1 RU situation. So Whether it would go all the way to that point, I simply don't know.
Okay. Let's see. How about this? Is there a cable fiber count that is more common or typical for the 200 micron fiber solution?
Yeah, that one similar to one we just had, I think. So it's other than being the larger fiber counts, I don't know if a particular size that is more prevalent, but I think the larger fiber counts, which obviously allow you to get the diameter of the cable down and the weight of the cable down and easier for handling, is going to be more prevalent there.
Excellent.
I see a question here I will tackle. I will take. So that it has to do with what are the downsides of the very small fiber connectors, very small form factor. Well, when you get that small, obviously then it becomes a little bit more tedious for the craft. However, I know those designers are working on push-pull boots, that type of thing, to assist the craft in handling. You're also going to have a lot of fiber jumpers coming out of those real dense panels. So obviously the fiber management, the management hardware, the connectors themselves, all that is going to be that much more critical. They have that much more fiber in it, and those connectors or that much more fiber relying on a single connection point and a single cable. So those would be the downsides, but I think the density gain for many people is going to outweigh any downside there.
Excellent. And Greg, do you see any on your display there that look like we have time to answer?
Let's see. There is a question about terminating the air core or no core fiber cable, and yeah, I do not know how that's done. So I apologies that I don't, but I'm not sure how that actually is, how those are terminated.
Oh, right. Well, let's see. And if anybody has any more questions too, you're welcome to keep sending them our way, and we'll try to answer as we can. Well, Greg, let's see. I've got a question for you. So what do you predict will happen to the industry in the next 5 to 10 years?
Well, and they're certainly better prognosticators than myself, but what we're seeing is certainly on the hyperscale level, they're looking at the very small form factor connectors, and the amount of density that they can get in the connectors, in the cables, in the racks, and just continuing to shrink that. So I think in the big picture, we're going to see, fiber density. The demand obviously continues to increase for bandwidth, and unless we see, some real significant changes with like the multi-core cables and multi-core fiber and things like that come along, I think we'll just see continued efficiency gains and getting the fiber as small as it can be gotten down to, and then the cable jackets and then all the connectors and things continue to get down to, as small as it's reasonably able to handle. I don't know. That's about as much prognosticating as I could do at this point.
Oh man, well, it's good for me. I appreciate that. So where can people find out more about this, or get in touch with you, or get in contact with the company to find out more?
Certainly reach out to your local Sumitomo Electric Lightwave sales representatives. Talk to our customer service team, our inside sales team, and you can get back to us, reach out to me, whatever, and we'll address your questions and help you where we can. You know, we're one of multiple competitors in this industry, multiple suppliers, and you know, some have things that others don't, and we're no exception there. But certainly we're willing to help. We have a great portfolio of products, and are very much want to see our products successful with customers, and customers successful because of our products. So you, again, reach out to Sumitomo Electric Lightwave, and we're very happy to assist.
Excellent. Let's see, do we have time for any more? Greg, do you feel like answering? I see a couple more.
Let's see. There's a question about labeling cables with small form factor. Yeah, that's obviously, as the cables get smaller, then labeling becomes more of a challenge. Of course, again, not being an expert on that, you know, some of those cables, there may be things like flag labels and things to try to use, but of course, flag labels, as most of you that have worked out there with many jumpers in a situation know, they can get kind of in the way when you're dealing with them. So you know, it is getting so small that it begs for, you know, maybe more electronic management of those cables and how that's done, or some continued evolutions even in the labeling of those cables.
Interesting. Very interesting.
And
yeah.
then,
So yeah, go ahead.
I'm sorry. Go ahead.
Yeah, if you see any others in there.
Here. Is the SWIC proprietary to Sumitomo or an industry standard? Now, that is proprietary to Sumitomo, to my knowledge. If it's not, then I'm not aware of that. To my knowledge, it's proprietary to Sumitomo.
Excellent. I've got another question for you. Are there questions you get asked a lot in your role? Some really common questions that people ask you?
Sure. Well, most of them have to do with specific product issues that you know, and supplying particular products, that type of thing. I do know that one of the things that we're asked quite a bit is about customizing products for customers, because once you get into, you know, with all these different evolutions going on, a lot of times people need products customized to just fit with different pieces of this evolution. And we really, that's something that we do a lot of. We really pride ourselves in that capability. And so I do get quite a few questions around that. And, you know, what different varieties of things that we customize. And for example, panel products and pre-terminated versions of panels and different varieties of things there. Also with cable assemblies, we're a manufacturer of cable assemblies, as are many people, and we, you know, there are often evolutions there, especially now with new connectors going to be coming onto the market. So you have to be able to evolve to adapt to those. So we get questions like that. I would say that's the most common types of questions that I end up fielding.